Hi there, Mr. Holcomb here with another lesson in pre-algebra. This is Unit 3, Lesson 13, Session 1, Terminating or Repeating Decimals. Write a rational number as a terminating or repeating decimal, and we'll be solving problems with rational numbers in different forms. So let's take a look. So Lupita, which is here, and Kevin, who is here, both walk to school. Lupita walks 3/5 of a mile. 3/5 of a mile. Kevin walks 0.65 miles. Who walks the greater distance to school? Okay, well, there's two ways we can do this. We can convert this fraction into a decimal, or we can convert the decimal into a fraction. And sometimes one is easier than the other, and other times the other one is. But in this case, I'm going to say 3/5 is going to equal 6/10 when I multiply the top and bottom by 2. These are equal equation, or these are equal rational numbers, equal ratios. Okay, now that it's 6/10, I can easily write a decimal, and it's 0.6. Okay, so that's Lupita. And Kevin walked 0.65 miles. So it says who walks the greater distance? So it's Kevin. So I'd say Kevin walked, and it is 0.05, because if I subtract 0.6 from 0.65, I get 0.05. So Kevin walked 0.05 miles further than Lupita. Okay. I could have converted this into 65 over 100 and reduced it and gotten, or at least gotten the same denominator. You want the same denominator when you're comparing. Okay. All right. So anyway, next problem. This is a duplicate. Let me get rid of it. And let's skip the connecteds. Whoops. Let me undo that. I do want to do part A. So connect it. Looking ahead. The number 3/5 and 0.65 are both rational numbers. A rational number can be expressed as a fraction or a decimal. All rational numbers can be expressed as terminating or repeating decimals. A terminating decimal has a decimal form that ends, or it ends in zeros. The rational number 3/5 can be expressed as the terminating decimal 0.6. Why is it not necessary to show the zeros after 6? In other words, why do I not have to write 0.60000? Okay, and the reason is, let's just do 1. Okay, well, 0.60 is 60/100ths. Okay, but I can divide both by 10. So when I divide the top and bottom by 10, they are still equal. And I get 100 divided by 10, 60 divided by 10, and that is 0.6. So if it's not necessary, we don't need to put it. The only time we really need zeros after this is if we're adding or subtracting from another fraction that has more decimal places. Okay. All right, part B. A repeating decimal, let me highlight that. A repeating decimal has a decimal form that repeats the same digit or group of digits without end. You can use ellipses, ellipsi, to show that the pattern of digits continues on without end. What is the repeating digit or group of digits of each repeating decimal below? So all I have to do is focus on what is repeating. So on the first number, I see that 3s are repeating. On the second one, it's 1, 2, 1, 2, 1, 2 over and over. And when you get to those ellipses, these dots, that means it's just going to continue. And in this one, you got to be careful. It's 0.0, but then after the 0, a 5 begins to repeat. So to answer this question, it says, what is the repeating digit or group of digits for each repeating decimal below? Well, the first one is 3. That's the repeating digit. The second one, it is 12. And on the third one, just the 5's repeating. Don't put 0, 5, because that'd be 0, 5, 0, 5, 0, 5. The 5 is all that repeats. Number 2, you can also write repeating decimals with a bar over the repeating digit or digits. Okay, so then we need to identify what is repeating again. This is all 4s, 4, 4, 4, 4. So a 4 is repeating. And this one, 502 is repeating. Okay, but that's it. 502, 502, 502. In this one, a 3 is repeating after the decimal. Okay, and then on this one, the 4 does not repeat, but after that, 2 repeats. Okay, so I don't like how they did the last one, and I'll explain that in a minute, but this is 4 repeating, so I would write 0, and there you don't need 2 zeros here, by the way. 0.4, and the 4 repeats, so you put a bar over it. The next one is 0.502, and the 502 repeats, so I put a bar over it. The next one is 3.3, and then the 3 repeats after the decimal. Okay, we don't want to say 3.3 repeating, because then it'd be 3.3.3.3, and there's no number with 2 decimal places. And on the last one, well, this is not clear enough. This is showing 4s repeating, and then they go dot, dot, dot. This is showing 502s repeating, and then they go dot, dot, dot. And this is showing 3s repeating, and then they go dot, 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 or the ellipses, okay? But this is saying 422 and then dot, dot, dot. Well, this makes me wonder, I'm going to wonder here, question mark, do they mean this? 0.422422 dot, 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 or do they mean 0.42 and just the 2 repeats? Okay, so which is it? They only showed us 3 digits, but then they said repeat. Well, what repeats? Everything after the decimal, like up here, or just the 2? So that I would probably say, because this is worded not so well, I'd put 0.42 and just repeat the 2. But who knows? Maybe they meant it was 0.422 repeating. But in that case, you should actually show it more than once. So I'm going to go with this. So maybe it isn't 422, 422, 422, because they didn't write it twice like they did here. Okay. So let's just go with the 2 repeating on that. So reflect, is the decimal 0.101010 repeating forever and ever and ever a terminating decimal or repeating decimal? Well, it's repeating because it has these ellipses. Okay, so it is a repeating decimal. And it says, how do you know? Well, because of these ellipses. All right, so 0.10 repeating, it's the 10 that repeats. So if I didn't write any of this, this would mean the same thing. And we have a rule in math that says whatever portion repeats, which is the 10s, you put over 9s in this with the same number of digits. Well, there's 2 digits in 10, so you put that over 9, 9. So I'm going to show that to you in the calculator. I'm going to take 10 divided by 99. And I should get 0.101010, and I do. Okay? So there's a little trick. Whatever repeats can be put over 9s with the same number of digits. So if I go back and do this 502 repeating would be, that's the repeating portion. Put that over 999, and that will be 0.502 repeating forever. And I can check with the calculator again. Okay, so what was it? 502 divided by 999. Whoops. And hit enter. And it's 0.502, 502, 502, 502 forever and ever and ever. All right, so a little trick on repeating decimals. And that brings us to the end of session 1. Hi there, Mr. Holcomb here with the rest of the lesson. This is session 2 from lesson 13, writing rational numbers as terminating decimals. Okay, so we're same learning targets as session 1, so I'll continue, skip past that. And connecting to context. Cities are often planned using a grid system with blocks that are a standard size. The blocks can be square or rectangular. Okay, so let's just skip that other question. And it says there are 20 blocks per mile in Terrace City. So this isn't really clear. 20 blocks per mile. I guess if you're walking down one street in a straight line like this one's shown, and you're walking this way, you go 20 blocks, you're going a mile. That's what they mean. Okay. So Tara walks 13 blocks, which since 20 blocks is a mile, 13's less than a mile, but it's more than half a mile because a half a mile would be 10 blocks, assuming all the blocks are the same. Okay. Her fitness tracker says that she walked 0.71 miles. Show if her fitness tracker is accurate. So here's what we're going to do. We want to focus on the givens. And so there it is. The tracker's in green, and what she actually did is yellow. So we want to compare the two. So I take 13 out of 20 because it wasn't an entire mile, it was less than. And I want to find out what that equals. Well, there's two different ways we can do this. When the denominator will evenly go into 100, we can just scale it up and say to ourselves, what is 20 times what? Or what do we multiply 20 by to get 100? And that is 5. So if I multiply the bottom by 5, I'll multiply the top by 5. And that becomes 65. Well, that is 65 100ths. So I write it as 0.65. Okay. And the actual was 0.71. So if I subtract the two, then we get 0.06 or 6/100ths of a mile. The tracker was off. Okay, it said she went a little bit further, but 6/100ths of a mile is not very much. Okay. We could actually find that. 6/100 equals 5,280 with an X on top because 5,280 feet in a mile. So if I cross multiply, I can find out how many feet 6/100ths of a mile is. And I'm going to do that just to show you accuracy. So 6 times 0 is 0, 6 times 8 is 48, carry the 4, 6 times 2 is 12, plus 4 is 16, 6 times 5 is 30, plus 1 is 31. Well, dividing by 100 will move the decimal here 2 places. So X equals 316.8 feet. Okay, so that's actually pretty accurate. If she walked 2/3 of a mile, the tracker's off by 316 feet. That's really not that much. That's the length of a football field. I guess it's enough, but you decide whether if it's accurate or not with those values. Okay, compare class strategies. There are 20 blocks per mile. Okay, we did it. We already did this. I'm going to skip it. We're not going to do the discuss it. And then they were showing how to do it here a little differently. And I'm not going to ever do it this way. Okay, this I think is more confusing, so we'll skip that, model it. This is how I did it in class. Okay, so this is basically this. You can do, if you can do this, it's easier, but if you can't, all they're doing is taking this 13/20 and writing 13 divided by 20 and adding a 0. So it's 13.0 divided by 20. And if I go back to this page here, there it is, 13.0 divided by 20. And when you multiply and keep adding zeros until we get down to no remainder, then that is our answer. Okay, so there's either way you can do it, whatever way you're comfortable. Okay, so I'm going to skip the connecteds and go to the next apply it. Alyssa plans to run 7/8 of a mile. Okay, so I'm going to highlight this. At one point, she passes a mile marker indicating she has run 3/10 of a mile. How much farther does she have to run? Okay, so again, I can take 7 over 8. And this time, 8 won't go into 100 evenly. 8 times 12 is 96, so I'm not going to do it that way. I'm going to take 7 and divide it by 8. I need a decimal and a 0 because 8 will not go into 7. But 8 will go into 70 8 times. 8 times 8 is 64. When I subtract, I borrow from the 7 and get 10 minus 4, which is 6. Bring down the next 0. 7 times 8 is 56. Subtract, and I get 4. Bring down the 0, and 8 goes into 40 5 times. Okay. So she has to run 0.875 miles on a trail. She has already run 0.3 miles. And here's a perfect example of when you need to put zeros after a terminating decimal. And it's when you're comparing, okay? So 5 minus 0 is 5. 7 minus 0 is 7. 8 minus 3 is 5. And then 0 minus 0 is 0. Okay, so how much farther does she have to run? 0.575 miles. Okay. Another way we could have done that is convert the 3/10 of a mile into a fraction. So then I'll do it up here. 7/8 minus 3 over, actually, let me do it vertically so I can write next to it the conversion. So we're subtracting 3/10 from 7/8, but I can't unless I have common denominators. So I'm going to make this 80. And then what do I multiply 10 by to get 80? 8. 8 times 3 is 24. What did I multiply 8 by to get 80? 10. 7 times 10, 70. Still subtracting. 70 minus 24 is 6. 6 minus 2 is 4. 46 out of 80, which reduces to 23 out of 40. Okay, so 23 out of 40 or 0.575 miles. Either answer I would accept. Okay. Apply it. Express negative 5/16 as a decimal. Show your work. Okay, well, that just means 5 divided by 16. I'm going to add a decimal and a 0. 16 won't go into 5, but 16 will go into 50 3 times. And 16 times 3 is 48, resulting in 2. Bring down a 0, 20. And 16 will go into 20 once. 16, subtract, get a 4. Bring down the next 0, 40. 16 will go into 40 2 times, and that's 32. Subtract and get 8. Bring this down. We're at 80. And 16 times 5 will give me 80, because 5 times 6 is 30. And 5 times 1 is 5, plus that 3 is 8. And we finally get a non-repeating, or no remainder, I mean. So if you have no remainder, you're done. And negative 5 over 16 equals this number, but it's negative because a positive divided by a negative, or a negative divided by positive, or a negative fraction is still negative as a decimal. So it's going to be negative 0.3125. Closing, exit ticket. Pause the video. See if you can do this. Unpause it, come back, check. Okay? So 40 will not go into 100 evenly, so I don't want to do it that way. So the only way I can do this is, well, there's two ways. I could put, either I could say 27 over 40, or I could do 675 over 1,000, right? 10th, 100th, 1,000th, 675 1,000ths. And then I could reduce. So let me do it this way first. I know 5 will go into 5, and 5 will go into a number that ends in 0. So 5 goes into 6 once with a remainder of 1. 5 goes into 17 3 times with a remainder of 2. And 5 goes into 25 5 times. Well, 5 will go into 10 twice, and then there's 2 more zeros. Okay. So if I see 40 here and I have 200 here, well, I need to divide by the same thing to get down to this if they're equal. So I ask myself, can I divide by 200 by something and get 40? Well, sure. 40, will 40 go into 200? Yeah, 5 times. Okay, so if I'm going to divide by 5 and divide by 5, 5 goes into 13 twice with a remainder of 3. 5 goes into 35 7 times, and look what it reduced down to. Okay, the other way I could have done it is check to see if this is the same decimal as that. So I could say 27 divided by 40. It won't go into 27, so I do this. And 4 will go into 27. 8 times 7 times 4 is 28. 6. 6 times 4 is 24. Subtract. 7 minus 4 is 3. Bring down this 0, 30. 4 goes into 30 7 times. That's 28. Subtract and get a 2. Bring down this 0. 40 will not go into 20. So I bring down another 0. And 40 goes into 200 5 times. Okay. Did I do that right? 6 times 4 is 24. Subtract, get 3, bring down a 0, 30. Okay, I think I brought down too many zeros, but the answer is 0.675, and it is equal. So are they equal? Yes, they are. I showed it 2 different ways. Okay, that brings us to the end of session 2. Thanks for watching, and have a great day.